We go on to talk about the nuclear particles, right? Let's see what happens to these nuclear particles, and let's enjoy. So we're going to talk about seven because the seventh one is not so important, but I'm going to give it to you because you get it in questions, right? Nuclear particle number one we'll talk about is called the alpha and alpha particle. These are the guys that you have um, either shooting out from the nucleus or whatever. They'll be coming from the nucleus. These are from the nucleus. Okay, that's why we do them in nuclear physics. So the first thing you can get from a nucleus is an alpha particle. An alpha particle is equivalent. Okay, it is the same as a helium nucleus. I will summarize it at the end and say more. When we talk about an alpha particle, we represent it with this alpha, right? The Greek word. And this is what it is. It has this configuration. Remember, this is nuclear notation, where the top number you put would be for the mass number, and then the bottom number would be for atomic number, right? This would be your atomic number, which tells you the number of protons. Then the mass number tells you the number of protons and neutrons. But remember that we said this bottom number is not only atomic number, but it is also the charge. Okay, it is also the charge. Let's talk. So right now we know that this thing has a charge of 2 plus. So we already know. So we can already see that our alpha particle will have a charge of 2 plus. And we said it is the same. You may see it being written as 4,2 then helium. But you are smart. You know that this is an alpha particle, 4,2 helium. We're not going to talk about helium in nuclear physics except for this situation. And it is not a helium atom. It is the helium nucleus. We are not including the electrons. That is why it will have a charge of 2 plus. The charge is going to be positive 2, okay? Or plus 2, right? Because it is the helium nucleus, not the atom, please. Okay? Then the second one we'll talk about is going to be called a neutron. Let's talk about a neutron. Okay? At this stage, we say that a neutron is a fundamental particle. A fundamental particle, which means it's something that comes, it's the smallest thing you could get from a nucleus. And what we're going to have is 1 0 neutron, like this. 1 0 neutron. This is going to be what? This is going to be the mass number. So it is a mass of 1. There's going to be the mass number, which is protons plus neutrons. Then here is going to be the atomic number and the charge. Okay? Atomic number and the charge. So that means this thing actually has 0 protons and a charge of 0. Okay? Because they go hand in hand. Now let's see the third thing. The third thing we'll talk about is a proton, which you all know. Proton, you should see the symbols. Can you see? Alpha is like this, or helium written for. Neutron will be written as 1 0 n. Then proton now we'll use a small p, and it will be 1 1 then p. Okay. Now this proton 1 1 p, like this. I've written it as 1 1 p. I want you to know more about this guy called proton. Why? Because he is. We have, when we put, this is our mass number, right? This is our mass number, which is protons plus neutrons. Then protons alone are also 1. So in actual fact, I'll tell you now, this thing has 1 proton only, okay? The atomic number is 1, which means it has 1 proton. What about the mass number? Is 1. So it has no neutrons there. This guy is the same is something very important, a type of a hydrogen isotope, which is called protium, right? So this guy, as we've seen here from alpha, it is the nucleus of helium. This guy is also the nucleus of somebody called a protium, which is a hydrogen. So you may see it being written as a hydrogen, which is 1 1H. But what you'll be knowing is it's not a hydrogen atom, it's the nucleus only. Okay, these are fundamental particles. These are particles. They are nuclear particles. They are not atoms. Please, they are particles that come from the nucleus. So this will be the same as a hydrogen nucleus. But hydrogen is different. Not all hydrogens are 1 1. There's hydrogen 1 1, there's hydrogen 2 1, there's hydrogen 3 1. Okay, protium deuterium, and tritium. Tritium is this 3-1. So these are 3-1s, and we look at this guy as our proton, right? And then I might as well then just show you the next guy, which is this 2-1. He's called a deuteron. Deuteron. You will meet him, right? Sometimes you see him as a small d, or sometimes you see him as a hydrogen. He will be as a small d. How do we write deuteron? 2-1, then we put a small d. That's a deuteron. Or we can also have it as 2-1, then hydrogen. That's a deuteron. A deuteron is made out of 1 proton and 1 neutron. You can see from these numbers here. This will be your mass number, which is proton plus neutron is 2. And then proton alone is 1. So that means there will be 1 neutron. Also to give proton 1 plus neutron 1 and add a number of 2. So this would be the atomic number, which is protons only. This would be our Z. Then the top number is your A. Never forget that. So we have deuteron. That is particle number 4, rather. Okay, that is particle number 4. So we can leave it there. So this proton, we said it would be as 11H, right? Exactly. This will be as 11H. It's your proton. If you see it like that, it is your proton. Please never forget it. You may get it as 11. It comes from protium. Okay, protium. The protium nucleus is called a proton. The deuterium nucleus is called a deuteron. And you can get it. It is sometimes short from the nucleus. Something that is exactly like the nucleus of a deuterium. And we call it a deuteron because of that. Then something which is exactly like the nucleus of a protium, we've decided to call it a proton. That's where the word proton came from. Now let's go to number 5. Our number 5 is going to be called a beta plus. Let's start with beta minus. Beta minus. Beta, we have beta plus and we have beta minus. Beta, the symbol is like this. That's the beta from the Greek alphabet. And beta minus would be an electron. It is equivalent to an electron. When we talk about its functions and when we look at it, its mass and everything. So it will be like this. Look at it. It will be 0 minus 1. Then you put beta. So now when you look at this, beta particles, when we talk about them, they actually, you say to me, this atomic number of -1, what does it mean? How can you have an atomic number of -1? Does it mean you have -1 protons? No, this will now just be the charge. The atomic number is gone. We said it is atomic number and charge, right? Here, and charge. This is also the charge. Don't forget that. So here's atomic number and charge. But for this beta, it is only the charge now. Atomic number is out. So we know that it has no protons. It is just having a charge of -1 because it is like an electron. So you can see it being written as just an electron to say 0 minus 1 electron, right? Because it is exactly like an electron. Mass number is 0. This is the mass number. That means it has 0 protons, 0 neutrons. It has a charge of -1. Okay? Then we go to number 6, which is beta plus. Beta plus. Okay, we can put it as a beta plus, which is just beta like this. Okay, which is just beta. And when you look at it, it is 0, 1. Okay, when you put it, it is 0, 1. Then you put beta. Okay, which is sometimes written as 0, 1 electron. Right? This is how you write it. And this beta plus particle, if you look at it, we say that it is just like, look at this. You say to me, it is just like a proton because it is this atomic number of 1, which means it has 1 proton. No, 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 no. It's not, because if you look at the mass number is 0. So that means it doesn't have a proton in it. It doesn't have a proton. It is just like a proton. It's a fundamental particle. We call this a positron. This beta plus, we call it a positron. This beta minus, we can just call it an electron. It's like an electron, right? It's a beta minus particle. It is exactly like an electron. This beta plus is called a positron. It is actually called a positron. It is its own particle. It is not something that comes from protons. No, it is a fundamental particle. In this stage, we call it a fundamental. At this stage, we call it a fundamental particle because it is just like a proton. It's just like a proton. But this is not, it doesn't have a proton in it because it's just like a proton. It's something that has a charge of 1, but a mass of zero. The mass is actually not 0. It's like 1 over 1830, like an electron. Okay, so it's 0,000. It's very small. This is again actually 1 over 1830, but it has so many zeros, so we just ignore it and we call it 0. Okay, a positron has the same mass as an electron. It has no proton in it because once you have a proton, you have a bigger mass. It has no proton in it. It has a charge of +1. Don't forget that is the charge. If you master this, then you need a big pizza. Number 7, the last one is going to be your gamma ray. This is the only one that is not a particle. It's a ray. It's not a particle. It's a ray of light, like a ray of light. And we represent it as 0, 0. Then we show gamma like that. This is gamma. 0, 0. Then you put it like that. That is gamma, right? This is no mass. It is nothing. It has no mass, no charge. Charge is 0. No proton, no whatever. But it has a lot of energy. If you look at something called the electromagnetic spectrum, which shows you all the different rays, the lights, all the different types of lights. We don't use all of them. Some of them, we can't see them, okay? But butterflies use a different type of light to us. That's why these animals that move at night, they don't use the same type of light as us. They can see when we can't see, right? So either way, these gamma rays, the type of light, it is the most energy of your electromagnetic spectrum. So if you look at your electromagnetic spectrum, you see that this gamma has the most energy. It has the highest frequency, the most energy. So this guy has a lot of energy, but he's just a ray, he's not a particle. And he can really penetrate and go deep, right? Can go deep. So anyway, these are the 7 that we've seen. We'll talk about them more and more and more, but you should know them. You should keep looking at them, see their mass and atomic number. But when we get to beta guys, these beta guys, they don't have any mass. This is their charge. Okay? Exactly. They don't have a proton or anything. So don't be confused by their numbers. If you're like that, then you're safe. Okay? That's it. Goodbye for now.